For number 13, we are told that the perimeter of triangle MNP is equal to 36. And we're trying to find the perimeter of the big triangle XYZ. Now we know from theorem 5-11 that MN is going to be half the length of XY. Or we can say XY is going to be twice the length of MN. So XY is twice the length of MN. ZY is twice the length of MP, and we also know that XZ is going to be twice the length of PN. So all of the segments on the big triangle are going to be twice the length of the segments of the small middle triangle, PMN. So because of that, if PMN, the perimeter is 36, then the perimeter of the big triangle would be double that. It's going to be 72. So the answer to number 13 is going to be 72. For number 14 through 17, we are told that AW, BX, CY, and DZ are parallel. And so these four lines right here are going to be parallel. And we are told that WX right here is congruent to XY right here, and that's congruent to YZ right here. So we are going to use theorem 5-9 in the textbook to answer these questions. So we're told that AD, the length from here to here, is 21. We're trying to find CD. Now we know that since all of this segment over here is broken up into congruent parts, then we can therefore conclude that AB, BC, and CD must all be congruent as well. So if AD is 21 and it's broken up into three segments, AB, BC, and CD, that means we can know that each part must be 1/3 of 21. So CD must equal 7. The same reasoning is used for number 15, where if BD equals 32, so BD is the length from here to here. If that is 32, we're trying to find now BC. So BC is going to be half of that because BC and CD are the same length. So because BC is half of BD and BD is 32, then BC must be 16. For number 16, we are told that AC, length from here to here, equals 5x minus 8. We're told that AB, length from here to here, is x plus 5. Well, AB, this segment, is going to be half of the entire segment all the way to C. So therefore, if we double AB, double that length, we're going to get the same length as AC. So therefore, if I take the two measurements, 5x minus 8, and set that equal to twice the length of x plus 5, I have an equation that I can solve. So I distribute the 2, and I get on the right side 2x plus 10. Now I can subtract 2x from both sides, and I get 3x. And I can add 8 to both sides. I'm going to get 18 on the right side. So 3x equals 18. Divide both sides by 3. I'm going to get x equals 6. So the answer to number 16 should be 6. And for number 17, we are going to use the same thought process that we used for number 16, where if BC, length from here to here, is 7x, then we also know that AD, length from here to here, is going to be 9x minus 24. Well, we know that BC, this length, is going to be 1/3 of the length from A to D. Because notice how it's broken up into three parts. Here's one part, AB is one, BC is the second part, and then CD is the third part. So we know that BC is going to be 1/3 of AD. So if I multiply BC by 3, that's going to equal the length of AD. So if I take 3 times 7x, I'll get 21x. That's going to be the same length as 9x minus 24. So when I solve this for x, I subtract 9x from both sides. I get 12x equals negative 24. Divide both sides by 12. I get x equals a negative 2. So the answer for number 7, and actually I'm sorry, I misread the problem. It should be 9x plus 24. So it should be a positive 24, so x should be a plus 2.